This is the end, beautiful friend. This is the end, my only friend. The end of our elaborate plans. The end of everything that stands. The end, no safety or surprise. The end, I'll never look into your eyes again. Can you picture what will be so limitless and free? Desperately in need of some stranger's hand in a desperate land. Lost in a romance, wilderness of pain, and all the children are insane. All the children are insane, waiting for the summer rain. There's danger on the edge of town. Ride the King's Highway. Weird scenes inside the gold mine. Ride the highway west, baby. Ride the snake. Ride the snake to the lake, the ancient lake, baby. The snake is long, 7 miles. Ride the snake. He's old and his skin is cold. The West is the best. The West is the best. Get here and we'll do the rest.
All right, so this is just a course retrospective. You've seen retrospectives before. We've posted them for every single assignment, every lab on Piazza. Retrospective is just a way to reflect and to, in a formal manner, and to think about what went well, what didn't go so well, so that what can you be identified for the future, right? I have this as a stand-up every week with my LAs, like what in the lab this week, what went well, what didn't go so well, what can be changed, or in office hours, or on assignments, right? First of all, your retrospective on me or on the course itself should be should be through the course evaluations. So the course evaluations are open in Canvas. I believe that they're open through the week after finals week, but don't quote me on that. So far, we have about a 26% completion rate for the honors section. I'd like to see at least 50% for all of them, but that typically without any sort of incentive or anything, we top out about 30 or 40%. But still, if you don't fill those out, then we interpret that as neutral, right? No news is good news, right? So it is your option to not fill it out. It is completely anonymous. We will never know who these 6 individuals are ever, and just what they commented. Unless they provided identifying information, don't do that though, right? Ultimately, those things are going to go into packets, and they'll go to other faculty too, so don't ever identify yourself for any reason, right? Keep it anonymous, right? Anyway, reflecting on, let's make sure that this works. Yep. Reflecting on what went well this course. So what are the lessons that you learned? What are the skills that you acquired, and what are the achievements that you've now unlocked? For example, soft skills, right? Hopefully now, not everybody chose to work in pairs, but those that do, those that did have some good experience now working in a team, at least in pairs. That means good coordination, right? Going back and forth, and good communication. Saying, I need you to do this, I'll do that, and you do that, and you go back and forth. I really think that we should go with this for the design. I really think that we should go for that to the design. Going back and forth and talking it out. If you didn't have, I don't think it happened in this section, but if you didn't have a positive experience, then maybe you still get some skills out of that, because you have to do conflict resolution. If you had hypothetically, if anybody had a partner that wasn't pulling their own weight, right, then hopefully you had that tough conversation of, look, I need you to do this, this, and this, and if it's not, then maybe this is not going to work out, and I need to find somebody new. You don't have that advantage in life, right? When you're working in a company, unless you're the boss, unless you're the manager, you don't get to fire people. You don't get to choose which team you work on. You get to choose which company you work at, but you don't get to choose the team in your company unless you're really, really lucky. In your future classes, you will not have the choice in a lot of them to work individually. And when you do work on a team, you will not have the luxury of choosing your own team members. So unfortunately, you will be working with somebody eventually that is not pulling their own weight, or that maybe got through computer, again, it's not really relevant to this section, but maybe got through computer science 1, computer science 2, farming all their work out to Chegg, right? And we just didn't catch them, right? Because we can't catch everybody. And they really don't know what they're doing, and it's going to be obvious, right? And you're going to have to work around that. If that means going to the instructor, whatever their process is for dealing with it, they're called 360s. Have you ever heard of that? So 360s are where you look around 360 degrees and you evaluate all of your team members, right? And that's your conflict resolution. Then you're really passive aggressive about it, because you never say anything in real life, but you just then you gripe about it and bitch about it all on your 360s. Don't do that, right? That's not good conflict resolution. That's not good teamwork, right? Good teamwork would head that stuff off at the pass before it becomes a problem. Hopefully you've expanded your toolbox. For many of you, you have now a 4th programming language. I'm including SQL in that. SQL is a fundamental data programming language. Now you have Java. Now you have Python maybe. Now you have C, right? In any case, you have object-oriented programming paradigm exposure now. Hopefully you've been using Git. If you've not been using Git, you need to get on that bandwagon there, right? It's here to stay. It's 20 years old. And it is the de facto way of managing code and managing complex code bases. 15 years ago, you would have said SVN. 20 years ago, you would have said CVS, right? Those were alternatives and then Git came along and blew them all away. There was another competitor at the time that still exists. Darn it, what's it called? Bitbucket came up with it. Anyway, I can't even think of the name. That tells you how popular it is, right? Git completely blew it out of the water, and it is the de facto way of doing stuff. So if you're still passing stuff back and forth through Dropbox or email or, God forbid, thumbnail drives, get out of that habit. Make sure that you're using Git properly. We give you enough experience to it, but it's not a Git course. So make sure that you're using, if you worked in a pair, hopefully you used it throughout the entire process. You now have experience in perspective building a larger project coming out of typical computer science one course. You may only have done weekly assignments, small weekly assignments that didn't necessarily build on each other. But now you've had experience doing that. You have had experience where we've set up the agile the development methodology, and we set up the sprints, and you built on those sprints. Hopefully you also have exposure to technical writing, right, with that design document. I don't know that I dove too deeply into any of them in the main section, since I had 20 to grade in Omaha and another 15 to grade sporadically through, in the main section, but hopefully that was a positive experience. Again, not everybody likes writing, right? Most people don't like writing, but it's a nasty fact that you have to do it, right? Even if you don't end up writing technical design documents going forward, if this is the first and last design document you've ever done, at least you've had some exposure to technical writing, and you can at least write a coherent email, right? That puts you above 99% of the people out there, right? If you can get your ideas across in a well-written email. Right? Hopefully you have a better appreciation of technical debt or eating your own dog food, right? If design did not come first and you just threw something together to get it to work, right? You now understand that you just took it out alone on your future time. Either you have to find time to do it right the second time, or you are spending time spinning your wheels fighting your design. In either case, you've taken a loan out on your future time. In fact, it's not even accurate to call it a loan, because when you take out a loan for $10,000 to buy a car, you know exactly how much you have to pay back. You know exactly how much interest you pay. You know exactly when to pay it on the first of each month. With technical debt, it's more like a blind call. With stocks, right? With gambling basically on stocks, where you could sell a contract to buy or sell 50 shares of Google stock at whatever the price is 30 days from now. Right? If the price goes down, right, then you just made some money. But if the price goes up, you're losing money. And guess what? There's no limit to how much money you can lose if you had a blind call like that. Right? So with technical debt, you're taking out a loan on your future time, but you don't know how much you're going to have to pay in the future. Right? Is it going to be 10 hours of rewriting, 20 hours of rewriting, 30 hours of rewriting, 10 hours of fighting my design before I finally give in and say, okay, fine, I'll rewrite it, and then another 10 hours to rewrite it, right? You have no idea, right? Because those things are not easily estimatable. Right? Estimable. Hopefully bad practices have become apparent why they're bad practices. If you had a bad design in phase 3, then you were fighting that design when you were making your sorted lists class, because you didn't design it so that an invoice knew its own total. Right? You had bad encapsulation or something where the total was computed outside the class, and now the list doesn't know these two invoices. Does it go like this or like this? And it has to go to a third thing instead of a comparator to find that information. It's not possible to design a designed list based on that. Hopefully the usage of good test cases and test suites also has become obvious. If you only did the bare minimum of testing and like you didn't test leases or something, and so when you go to grade and all my numbers are off because you never tested it, because you never saw that you had to include both the beginning day and the end day. So it's always off by one day. That's an easy fix, but if you had a test in there To begin with, you wouldn't have had to debug it using our grader like that. In the real world, you don't have a grader, right? You're writing the tests as well, right? And how do you validate those? You have to go back to the business folks. You have to go back to the stakeholders and say, is this right? And they'll go, it looks right. That ain't good enough, right? Then at the end of the month, when all the numbers don't add up, who's to blame, right? Well, the test suites, right? A lot of software development is CYA. Anybody know what CYA stands for? I think we've talked about it before, right? Cover your ass, right? So the whole point of engineering is to make sure that when things fail, it's not because of you. It's somebody else that you can blame, right? And so having good test cases. Nope, all my test cases passed. I had good code coverage. It was efficient. I had 50 examples over here of everything passing. So what didn't pass? Why did it fail? Oh, because you gave us bad requirements. There you go. It's your fault, right? And being able to blame somebody else. First of all, it's a nice warm feeling inside when you can blame somebody else. But also, it's CYA, basic CYA. Right? Poor variable names. That's not that big of a deal. Hopefully you've broken yourself of those kind of bad habits out of a computer science 1 course, but it never fails. That many of the bugs are because, well, what's that variable for? Oh, it's to control when the loop should end. I go, well, why does it say when the loop should not end, right? It was not apparent at all from that variable name. And once you rename it, then your logic says not should not end or whatever, right? Like, simplify that. That's why it's not your loop. You're in an infinite loop or whatever. Hopefully you've seen some examples of over-engineering, right? A database with, say, 50 different tables, right? 1 table for every subclass. So you had an item table and the 3 subtypes and then the 2 equipment subtypes. And you had 6 tables when 1 table would have done well enough, right? Yagni, you ain't gonna need it. That's over-engineering. And now that you've got 6 tables, now you're having to write, 3 times as many queries when you actually go to put stuff in your database or take stuff out. Or you're having to do overly complicated joins that don't work or that are slow, right? Hopefully you've seen that kind of bad database design. And again, that's not bad database design. It's just that it's over-engineering, right? You ain't gonna need that. Hopefully you have a better appreciation for the scope of a larger project, coordinating in teams, et cetera, et cetera. I always tell people in Computer Science 1, look, not everybody is going to come in with the same level of skill. Most people are going to come in with 0 skills at all, right? Don't compare yourself to that individual over there that took 4 years of Java and Python in high school, and before that was designing and implementing Roblox games in Lua, and they made enough money to the equivalent of 20 Robux or something like that, right? Don't compare yourself to that person, right? They've got way more experience. Compare yourself to yourself. The best student evaluation that I ever got, the comment that I ever got was, when I came into this course, and this was Computer Science 1, but it was at the end of the second year, at the end of the first year. When I came into this program, I had difficulty writing a basic FizzBuzz program, right? It took me hours to do that. But at the end of the first year, I'm looking back at myself, and I'm a coding machine now, right? You could go back to the very first FizzBuzz assignment that you did, and you could probably hammer that out in a couple of seconds, right? If you go back to the beginning of the semester and look at that first phase, you could probably hammer that out in a matter of maybe an hour. Maybe it took you 5 hours before, maybe it took you 10 hours before. Now it's only going to take you 1 hour. Compare yourself to yourself and the improvement that you've seen from the first day to now, right? And if you can honestly say, yeah, I've improved, I could do that stuff way easier now, right? Then that's an achievement. Right? What were the impediments? That was the good. What's the bad? Right? Once again, it doesn't really apply. We'll take a look at the grade distribution in this course in a second, but it doesn't really apply to this course. But most people fail STEM courses, period, by never getting started. It's really difficult to cross that finish line if you never get out of the gate. All right, and that the data shows that. We'll take a look here in a second. But the other impediment is procrastination. I try to fight this with tools like the Gantt chart. I'm not under any delusion. I don't use a Gantt chart in my daily life. But I still am organized. I still have, I use Google Tasks, both weekly tasks and daily tasks. And also when it's a one-off thing, I put that in a to-do list with reminders. I organize my email. The snooze feature is the best feature ever introduced into email clients. That I know that, okay, I've talked to this person, and I'm going to follow up. And if they're never, I never trust anybody to follow up. So I'm going to give them a week. Right? I snooze that email so that when it wakes up 1 week later, I email them and I ping them and I say, hey, have you had a chance to look at this? Right? Always be following up like that. Always have a plan B, because never, what is it? Trust but verify. Right? Trust that other people will come through. But always have that plan B for when they don't, right? Because that, more often than not, plan B is probably going to be end up being plan A, right? Because plan A is going to fail. So whatever you do to self-organize and, frankly, organize others, right? In software development, we have something called drop-dead dates, and I can't believe that more people don't take advantage of this in real life, right? Agile development is software development where you have self-organized teams. You don't really have bosses coming in and telling you what to do and when to do it. Instead, the team self-organizes around that. Well, what happens when a team has an external dependency? When team A, to get this done, we need that component over there from team B, right? And if we don't have that component, we can't continue our work, right? We're stuck. So that's when you set up what's called a drop-dead date. We'll say, look, we can commit to this work and we can commit to getting it done by XYZ date, but that is a dependency on this thing over here. And it sets yourself up, so again, CYA, and to be able to blame others. That if they don't come through, if you don't come through by this date, then it's a drop dead date. We're not going to be, our commitment goes away, right? If you don't deliver that component by the 3rd of February, right, then we're not going to be able to get this done until 3 months from now, right? That adds 3 months onto our scope. If you plan, right, if you plan it out and have understand those external dependencies and build that into your plan, then you're going to be way better off. Because if you never put that into your plan, never had a drop dead date, you just sit there twiddling your thumbs until they finally do, sorry, that was actually done last week, here you go, right? Well, sorry, nope, we're not committing to that, right? And then you can codify it by getting a lawyer and having a contract drawn up with codified drop dead dates. Right? Especially if you're a independent contractor. I don't know if anybody paid attention to any of the recommended videos in Computer Science 1, but one of them was at the very end is what happens when you become an independent contractor. First of all, you charge 10 times as much as your salary should be. Right? Don't think that you're going to be making 10 times as much money. Right? Because then you're paying your own taxes, then you're paying your own payroll taxes, then you're paying your own expenses, you're paying your own insurance, et cetera, et cetera, et cetera. So yeah, that 10 times as much dwindles really, really, really fast. But you're your own boss, right? Not if you ain't got a lawyer, because the lawyers are the ones that make sure that your clients pay the bills, right? And there is an excellent, absolutely essential watching for anybody thinking of being their own independent contractor. They say the full word, but it's called "FU, pay me," right? And this guy goes through his entire career where they started out, with handshakes and trust, and and then the clients wouldn't pay. I don't like that work, right? Or that's not what we wanted. Or that project has been canceled. Guess what? FU, pay me, right? That's what you need to. That's what you need to do when you're an independent contractor. Absolute great watch of a video. If you go back, it's still up on Computer Science 1. And it all goes into planning, right? You really can't draw up a contract for somebody to sign if you don't plan yourself. Right? Agile development is kind of like that in that at the beginning of a sprint, sprints are typically 4 weeks. Ours were 2 weeks because it's a course. But at the beginning of the sprint, your team gets together and self-organizes and sees all the tasks that have to be done, right? And you're not going to get all this done in the next 4 weeks. So we'll commit to that, commit to that, commit to that. The product owner, the manager, the traditional manager comes in and says, actually, this is our priority, this is our priority, this is our priority. Okay, fine. We can commit to that and that, but not that, because we can't do that in 4 weeks, right? And they're not supposed to be able to say, no, you will do that in 4 weeks. The team is responsible for their own management. Now, that 4 weeks, you commit to that work, you'd better make that commitment. If your work looks like this, you get everything done on the first day, you're lying about your commitment, right? Go back and re-estimate. Right? That's the Scotty principle, right? Where, oh, that's going to take me 3 weeks. Get it done in 2 seconds, and then take the next 3 weeks off. You can't really do that, right? Especially when you are in a team of other people who are competent and know now somebody's going to be honest in there. You also don't want it to look like this, where it's, going across, we're not getting any work done, but in the last 3 days we cram and get everything done, right? You're not working your best. That's not the best design. That's not the best work. You can't cram, right? You can't cram and have it be quality. There's something called the iron triangle of product management, or project management. You can do it cheap, you can do it fast, or you can do it correct. Pick 2 of those. I suppose you could pick 0 of them, but at most you could ever pick 2 of those. Because if you do it cheap and fast, then it's probably not going to be correct. If you do it fast and correct, guess what? It ain't going to be cheap, right? You're going to have to be paying for that overtime or whatever. And so agile software development is your opportunity to make sure that you have this nice linear, it's called a burn down chart, where you start up here and then you're working at a constant pace. And at the end of the month, you're at 0. You've done all the work that you committed to. But you didn't have these peaks where you were doing a whole bunch of work and these troughs where you were idle, right? You want a nice, predictable workflow. Right? That's the goal of agile software development. And that is the de facto way of doing things in today's world. Make sure that design comes first, because if you procrastinate, the other thing that I've tried to do to fight procrastination over the years is to introduce that design document and have it due 1 week before you actually start, before the actual phase. That forces you to think about the design. It gives you an opportunity to get feedback early about the design so that you can go back, oh, wow, yeah, I didn't foresee that problem, right? And unfortunately, the process is always, subject to flaws in the process, but hopefully that, for the most part, for the majority of people, Pareto principle or whatever, that it did work out that way, right? Again, your course evaluations are your opportunity to tell me, it didn't work out that way. Here's how it could work out better, right? Hopefully insufficient testing has also exposed why that's a bad practice. If you can run code, you can run tests. If you can write code, you can run repeatable tests. If you can read code, you can write proper unit tests. I put this one last, reading code, because it's actually the most difficult thing to do. If you've ever heard of Bloom's taxonomy, it's an educational theory where you've got lower order cognitive skills down here, understanding something, right? Yeah, I understand a loop. Up here, or down here in the middle, you have creation. Or no, up here for traditional Blooms. Up here you have creation. You can create your own software. Understanding versus creating is actually flipped with respect to software, right? It is much easier to write your own code than it is to read and understand somebody else's code. This is actually a higher order cognitive skill with respect to code, right? Because not only do you would have needed to be able to produce this in order to understand how somebody else solved the same problem. So if you can achieve that, if you can read other people's code, then you can write proper unit tests to try to break it. Right? When you read somebody's code and say, oh, you know what? I think that would have an overflow error. Or I don't think that they ever considered inserting into an empty linked list, or inserting at the head when there were 5 elements in that linked list. I'm going to write some proper unit tests here to try to break that code, to fuzz that code, right? To cause chaos to that code, to try to break it. And if you can do it on your own code, that's an even higher order cognitive skill. Right? The skills for this course, traditionally courses identify the topics covered. With a skills-based course like this, computer science is always skills-based. I like to term it in terms of skills outcomes or skills objectives. Now having 2, 3, 4 programming languages, you should be able to pick up a new programming language like that, right? And people do, right? When I offer a VR course in the spring semesters, and we don't cover C#. Right? I give them a couple tutorials on Unity just to get started, but if you've seen Java, then you can program in Microsoft Java. That's C#. That's the joke, by the way, right? That C# is just Microsoft Java. But you should be able to pick up a programming language on your own with no problem, and that will be expected. You should be able to recognize, use, and design and appreciate programs with an object-oriented flavor, right? Object-oriented programming flavor. You should be able to design a database-backed application from scratch given a general problem statement. You should be able to recognize and know when to use and leverage basic data structures. Oh yeah, that's a stack over there. Or a queue would be great for that. Or, hey, a heap will let me pull things out in a priority queue or something. You should be able to identify and analyze basic algorithms as well. Again, one of the themes of this course is smart data structures and dumb code work a lot better than the other way around, and hopefully you have an appreciation for that now. Because at the end of the Computer Science 1 course, you should be able to take a high-level description of a problem, design a top-down solution. In other words, break it up into smaller and smaller chunks until, oh, that's a library function over there, or that's just one line of code. Right? But at the end of a Computer Science 2 course, you should be working in the opposite direction. You should work from the bottom. What entities, objects, or classes should I be using to model this problem? Well, I've got invoices. I've got items on those invoices. So there's an invoice. There's a list of items or collection of items. I've got a person and their emails. There's a person class and composition. They've an address. Oh, that's 5 things. I need an address class now, etc. A store class. Well, I'm going to have a report that tells me how many sales were at this store. So probably the store needs to own a list or a collection of invoices. Right? So how do they interact with each other? Those are the questions you should ask first. What data structures can you pull off the shelf and throw at this problem and have dumb code? Right? All I have to do is put stuff in and take stuff out. Magic, it's done. Right? Because I know about that data structure. Oh, a linked list? I shouldn't be using that, or at least I shouldn't be using that in this manner, because I know about the painter guy that doesn't pick up his paintbrush and always starts at the beginning, right? So those are the questions you should be asking first, bottom-up questions. The big takeaway from this course is that you may have done some things, or maybe a lot of things, poorly or wrong. Doesn't matter. That's part of the learning process. All right? Next time you do something like this, you'll do it better. The third time you do something like this, you'll do it even better. The fourth, fifth time, you'll get better and better and better and better. Compare yourself to yourself, not to others. The other key takeaway here is, I don't know if computing disciplines are unique. I think they are, because we're special. Computer scientists, computer engineers, software engineers, they all have to be lawyers, philosophers, diplomats, managers, designers, creators, thinkers, programmers, thinkers and programmers, right? So first of all, why do I say that they have to be all of these things? Think about any other discipline, right? That discipline is probably going to be obsolete in 5, 10, 15 years, 20 years, if they don't have some sort of computing component, right? In other words, computer scientists are at the center of all of this stuff. And all of these people are eventually going to have to become small computer scientists, right? And therefore, computer scientists have to be small lawyers, like a little bit of a lawyer, a little bit of a philosopher, right? If you doubt any of these, right, I can give you multiple examples of when you've had to do these things, or I've had to do these things. Right at the top here, lawyers. Just this last week, I've shared this story now a couple of times. I had to deal with copyleft trolls. So copyleft is where you're publishing something under a Creative Commons license for free use. All my books are released under a Creative Commons license, but they're released under a share for attribution license. In other words, you can't just take my book and cross out my name and then claim it as your own, right? That's not part of the license. But you can take my book, you can print it, you can change it, you can give it to people, you can use it in your class, you can do whatever you want with it as long as my name stays on it, right? Copyleft trolls, like Pixie.com, sign contracts with people who release stuff, or people who release stuff under a Creative Commons license with the intent of becoming copyleft trolls. Copyleft is just the opposite of copyright, right? So they've got copyrights, and they say, if you don't put my name on there exactly as this appears, then it's a violation. And so they lawyer up with these automated services that go out with bots, try to detect this stuff, and then, again, automate and send out emails threatening legal action. Don't worry, you can go ahead and take care of this right now by paying us $750, right? It's just a legal shakedown that should be ignored, right? You need to be a little bit enough of a lawyer to know that you don't talk to them, right? Just like you don't talk to cops, you don't talk to lawyers. What do? You get a lawyer, right? There is a reason why people say, like all the cop shows say, you have a right to remain silent. Take that right, remain silent. Right? You are not a lawyer. You don't know how to speak to other lawyers. You don't know how to respond to legal threats. Lawyers do. I didn't respond, right? I worked with UNL's general counsel to come up with a resolution. A colleague didn't know that they shouldn't be a lawyer, and they responded, and they could have put us in a very bad situation where they were apologizing and saying, sorry, we violated your copyright laws, we'll rectify this immediately, right? You just admitted guilt. That's gold to a lawyer. Never, ever talk to lawyers, right? Get a lawyer to talk to lawyers, right? And maybe if you've got an incompetent lawyer, then you're out of luck anyway, but no, you need to be enough of a lawyer to know that you're not a lawyer, right? And make the lawyers take care of it, right? Philosophers, you need to be able to coherently argue your point of, I thought I like this design for X, Y, Z. Right? Well, I like this design for X, Y, Z. Yeah, but did you think about CYK, right, or whatever, right? You need to have that kind of, I forgot the word. I said the word yesterday. Dialectics, right? Being able to argue and being able to articulate your point and understanding somebody else's point. Seeing it from their perspective. People call that emotional intelligence now, right? It's just philosophy, right? You need to be diplomats because you need to work and have that kind of conflict resolution. ... Why did I put programmers way down here at the bottom, the very last? I forget who posted it. Was it last semester or the semester before? Somebody posted a meme from Programming Humor where the novice is programming 10 lines of code per minute or per hour or something. Right? And then the intermediate, once you learn something, you're now programming 100 lines of code per hour. Oh, wow. Now you're almost an expert. You're programming 1,000 lines of code an hour. You're just hammering out this code. But now, the super expert, the really smart expert, how many lines of code are they producing an hour? -3. Why? Because they're taking the garbage away. Right? You don't need that. You don't need that. I'm going to replace this 50 lines of code here with a data structure. You don't need that. You don't need that. Right? How do you know that something is done? How do you know that something is perfect? Not when there's nothing left to add, but when there's nothing left to take away. Right? So programmers, yeah, you'll end up doing a lot of programming at the beginning, but as you get better and better and better at it, you do less and less and less. As your career moves forward and moves forward and moves forward, you're doing even less over time, right? Until you're a manager or you're an architect, and you're just saying, okay, we're going to use this pattern, this pattern, and this pattern. And you dictate that to the team, and they know what they're doing, and they'll implement those patterns, right? So programming is actually going to be a very small chunk of what you do. But understanding programming, that's a huge chunk of it. Right? There's, there's the main section. We'll come back to that. Here's this section, doing very well, in fact, historically well. Nobody dropped, nobody's going to fail, right? At least as of now. This does not include assignment 7, 8, or the design document, right? But I anticipate that everybody will do well on those. Everyone, right? I do not have, so from a historical perspective here, even the honors section is doing better than history. You usually have 1 or 2 people fall by the wayside or decide they don't want to be computing majors anymore or whatever, and they drop. But we've got 100% pass rate here, right now. Please maintain that, right? But otherwise, if you look at the main section, the typical DFW rate amongst computing majors is about 20 to 30%. Overall, that's comparable to this year. Is this a good thing? Is this a bad thing? I'm not going to make that value judgment. I'm just going to tell you that it's a normal thing. Right? That's what it typically is, historically. Right? Why? Well, here's a histogram of a week-to-week grade distribution for the main section. Right? Week 0, I give free starter points. Everybody's passing with an A. Week 15, everybody's failing. No, that's just because we haven't graded the last stuff yet. Only look at 14 here, right? Week 2, 1 or 2 people didn't even do their lab, right? What happens in week 3 here? What was due in week 3? First assignment, right? And how many people ended up failing right out of the gate didn't even exit the gate, right? That's pretty much everybody that fails in the end, right? So, solving this problem is not a, oh, well, okay, we'll solve this in week 7 problem, or we'll solve this in week 12 problem. It's a solve it before the course even starts problem, and I have no idea how to solve that, right? These C's right here were because they did the gimme problems, right? Those first 2 problems of computing the volume of a corn silo. I mean, come on, anybody that completed with computer science 1 should have been able to do that. But clearly, a huge chunk of folks got out of computer science 1 here without being able to do that. Right? Again, this is not this course, this is the main section. Right? My comment on this is, how did they get out of computer science 1? Well, maybe they did honestly do well, right? But we're not going to catch everybody on Chegg. We're not going to catch everybody who mooched off of a partner too much, or undermined their own learning experience in one way or another, right? But I will tell you that these people are still going to get through. Even some of them are still represented right here. In other words, you're going to have to deal with them, right? You're going to have to deal with this in your future. You're going to have to deal with colleagues at a workplace situation where they're not pulling your own weight, right? I always post the brilliant Paula Bean, and that is an intentional misspelling, right? Have you ever heard of this website, the Daily WTF? I don't know if it goes anymore, but it's coding stories of like horrors, right? The daily what the F, right? And so this story here is about a consultant, or an independent contractor, who they brought in to design and build this system. And she kept giving them updates, and I'm sure that the name is not real. And I kept giving updates and stay, yep, everything's great, great, except for the week that it was due, and tells everybody, well, I kind of need some help. All right, well, show me your code. And there's her code, right? And Paula is brilliant. She couldn't even spell brilliant right. Again, this is probably highly redacted, names changed. It's probably not exactly what happened, but the real WTF is that there were no checks. Right? There were no checks. If you're paying a consultant over 3 months, and you're never checking their daily work or their weekly work somehow, that's on you, right? Good on Paula for bilking them for however much she was charging, right? But honestly, you will have to deal with people like this that get the job because of their excellent CV or resume writing skills, that get the job because of their cram skills and ability to schmooze in an interview, right? You'll have to work with people like that eventually. You'll have to work with people here in the department like that, right? So I'm just giving you a heads up that you need to develop the soft skills to deal with it. You need to develop those conflict resolution skills to head that problem off at the pass and have those difficult discussions. Right? But otherwise, I didn't do a histogram of this course because it wouldn't have looked anything like this. All right, so end of the course. You still have assignment 8 and the design document. Make sure that you're reviewing our feedback that we've given in the documents themselves, but more importantly, anything that we've posted to Piazza, because those are general tips and tricks for what needs to be addressed. Obviously, there's no final exam. There was never any exam in this course. Like 5, 6, 7, 8, 10 years ago or whatever, I used to have exams. I used to have a midterm and a final. They were all Scantron exams so that I didn't have to grade them. over time, I went from like 20%, 30% weightage on those exams to 20% to 10% to 5% to throwing them out entirely. Why? Each time I reduced it, the grade distributions never changed. Right? So why have the final exam when when the assessment on all the assignments is exactly the same? Right? Why have an exam at all? Right? And I've turned around into a firm believer in formative assessment rather than summative assessment. Right? The traditional STEM class where you've got 90% exams and you've only got 2 or 3 exams. Right? So one failure, you're done. Right? And if it's the first one, then your semester is screwed. If it's the last one, you wasted your semester or whatever. Right? I don't believe in that. And hopefully more people are coming around to that idea. Where you should be able to submit and resubmit as many times as you want. You should be able to come back and resubmit an entire assignment at the end of the semester, which is why I do that. Final stats will, of course, be posted. Otherwise, where do you go from here? Grading is never perfect. Right? We might have missed stuff. Right? You might have had a bad design, and you might have had an LA that missed that bad design, or 1 or 2 things in that bad design. And those carried through, and you never realize the mistakes. That's unfortunate. I mean, nobody's perfect. I'm sure that when I grade, I miss some things here and there too. Right? Apologies for that. But what you should do now is, if you do think that you were the victim of overly generous grading, well, talk to each other. Talk to LAs. Like now that it's over, you can share your code with each other. Look at my code, you look at your code, and oh, well, I wouldn't have done it that way, I did it this way. Have those kind of conversations. Right? As far as academics go, I think most of you are taking 235 or 235H right now. If not, that's the next course. But otherwise, the next course in the fall is 310. The honors section by Hao Chan is 310H. Otherwise, I think that there may be 2 other sections. Don't know how big they are. I don't know who's teaching them, sorry. But otherwise, that's a continuation of this course right where it leaves off. Data structures and algorithms. Where do you go here from being professional in your professional life? If you have an internship, great. If you don't have an internship, make sure that you're going to the career fair in the fall and the spring to get that internship over the summer. You are more than qualified for that first internship right now. You're more than qualified for that after your first course, trust me. Right? Stay frosty over the summer. Even if you don't have an internship, learn a new language. Or if you do, right, learn a new language, build a new project. If you want to get into game development, get into C# and Unity. If you want to do some, data science-y stuff, big data number crunching, pick up some more Python. Set up a chat GPT client or something. Do something like that, right? Do something new, right? Not just with your internship, but something else. Make sure that you stay in touch. Bits and Bytes is published, I think, weekly or monthly over the summer, but it still will be published. Stay in touch through the Student Advisory Board and their Discord. Pretty soon here we're going to have exit interview data. Each year I post aggregate data of where students have gotten their jobs, how many students got their seniors now. This is senior exit data. Where they got the jobs, what the average salaries were, what the average in-state versus out-of-state salaries were, so that you know what you need to be asking for when you go in to negotiate. Right? Negotiation skills are actually another one of those soft skills that is severely underdeveloped in folks, right? Myself included, by the way. I should be negotiating for a lot more after seeing some other folks. Anyway, I won't get into that. Make sure that you're joining that Discord so that you can see that transparency of data. I will be posting that so that you know, it's not typical, but last year somebody reported a salary of 170K to Amazon, right? So again, that's not typical. That was all benefits, all the signing bonus included, right? Then somebody goes, I won't name any local companies, but then somebody goes to a local company and gets 35K, right? They undersold themselves severely, right? There used to be a website based on this. It was glassdoor.com. Unfortunately, it's been taken over by employers wanting good reputations. It was a way to review employers and say, no, this employer sucks, their culture sucks. Here's my salary, by the way, right? And here are my coworkers' salary. The only people that benefit from the lack of transparency of salaries are employers. You will never benefit from a lack of transparency. You benefit from transparency. And so I'll be posting those in the Discord later. There's a QR code for an invite if you're not a part of it already. Otherwise, thank you to all the students who helped out on Piazza. Thank you to all the learning assistants especially, and the course leaders who helped out throughout the entire year. Thank you to all of you who took the course. Anybody who's watching the live stream, which is 0. You'll watch it later, I'm sure. Right? And thank you for watching it later. Otherwise, have a great summer, and if I see you around, or if I see you in the UNL Game Development Club, I'll give them a plug here. I'll give another plug to the RED teams. That's the Engineering, Research, Education, and Development, I think, teams. I am a faculty advisor for the NASA Suits team that had one of their proposals accepted. Next week, they'll be going down to the Johnson Rock Yard at the Johnson Space Center and testing out their HoloLens product that they built. And it's all because they saw one day that in Bits and Bytes, oh, Red Team is looking for members, right? Maybe I'll go and join that thing. And now they're all spending a week at NASA next week, right? Showing off their stuff and getting the red carpet treatment from NASA. So you only know about those things if you read, right? And you get engaged. So join the Discord, join the UNL Game Development Club, the RED teams. OS2G is another one I would recommend. And I only recommend these 3 because I'm involved with all 3 of them. There are many more opportunities out there that I am not intimately familiar with that are just as good, a great experience that you should find out about. All right, then have a good summer.